With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, the question is what transition in the hydrogen spectrum would have the same wavelength as Balmer transition n is equals to 4 to n is equal to 2 in the helium plus spectrum. So in the question it is given that the transition in hydrogen spectrum would have the same wavelength as the Balmer transition, that is from n is equals to 4 to n is equals to 2 in the helium plus spectrum. So we have to find out the transition in the hydrogen spectrum. So it is given in the question that the wavelength of He plus, that is helium plus, will be equals to wavelength of hydrogen. Now wavelength is calculated as one by lambda, that is for a transition when it takes place from n1 to n2 or n2 to n1, then 1 upon lambda equals to RH into z square upon 1 upon n1 square minus 1 upon n2 square. So by this formula we can calculate the wavelength. Now if we write the transition, Balmer transition, n is equals to 4 to n is equals to 2, then the lambda will be, if we write 1 upon lambda helium plus equals to RH, and for helium Z will be equal to 2, so it will be 2 square into 1 upon n1 square, so n1 will be 2, so it is 2 square upon into 1 minus 4 square, so this will give us 1 upon lambda helium plus RH into 4 into 1 upon 4 minus 1 upon 16. So this will give us 4 RH into 3 by 16, and 4 is cancelled by 16 by 4, that is. So we have the lambda of helium plus as 4 by 3 RH. This is the lambda of helium plus. Now if we write for the transition of hydrogen spectrum, for hydrogen Z will be 1, so if we write 1 upon lambda H, that will be equals to RH into Z square, so it is 1 into 1 upon n1 square minus 1 upon n2 square. So we have to find out n1 and n2, that the transition has taken place from which energy level to which energy level. Now so this lambda H will be equals to RH into n2 square, 1 by lambda H will be equals to RH that will be equals to n1 square, n2 square, n2 square minus n1 square. Now if we reciprocate this, then it will become lambda H is equals to RH into n1 square, n2 square divided by n2 square minus n1 square. Now in the question it was given that the wavelength of the He plus will be equals to lambda H. Now we have calculated the wavelength of He plus transition, so that will be equals to 4 by, this will be in denominator as 1 upon RH. Now if we put lambda H is equals to lambda helium positive, that will be 4 by 3 RH equals to 1 upon RH n1 square, n2 square upon n2 square minus n1 square. So this RH is cancelled by RH. Now we have n1 square, n2 square divided by n2 square minus n1 square is equals to 4 by 3. Now if we compare them, we get n1 is equals to 1 and n2 is equals to 2. It means the transition has taken place from n2 n is equals to 2 to n is equals to 1 for the hydrogen spectrum, which has the same wavelength for the Balmer transition in the helium plus spectrum. So the correct option for this question is D option, n is equals to 2 to n is equals to 1. I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.